Welcome to a lesson with Dr. Powell. Let's take a look at the proof in a circle that, given an arc and a point opposite it, or somewhere on the circle, it could be over here, wherever, okay, like this is call this an inscribed angle. And then if we just go from the center of the circle and we draw lines like this, all right, so call this angle A, call this angle B. A is called a central angle, B is called an inscribed angle for this particular arc, and we have a fact that A is actually double B. Let's actually prove that. Okay, now to do that, what we're going to do is we're going to draw an extra line. So right here, draw an extra line that comes in like this, the other side of the circle, and okay. So, and what have we done? We've made a bigger arc, all right? It goes like this. I'm going to call this angle right here C, okay? Because we kind of created a new one. And see, we have another central angle going on right here. I want to call that, maybe give that a name, D. All right. Now, notice, so see this radius here and radius here of the circle, those are the same length. So it means that we have an isosceles triangle going on here, which means that this angle right here is C as well. So, well, C plus an angle that comes right here in the triangle is going to be 180, right? Thinking of this triangle. So I'm going to outline it. So this triangle right here. So just think about the angles in this triangle, right? C plus this angle right here is going to be equal to 180. But A is still going to refer to that angle right there. So maybe I'll just take that off. Okay. So so knowing that, notice that D plus that angle right there is also 180. That immediately tells us that 2C is equal to D, because both of them represent the unique angle that I have to add to this one right here to make 180. Okay, so 2C is equal to D. Well, this is really nice because this is a central angle, and this is actually an inscribed angle for that arc, and we've actually shown it for this particular arc. But what's unique about this arc is that one of the lines goes through, is the diameter of the circle. Now, okay, so that same idea should hold for any central angle, inscribed angle relationship where you have one line as a diameter in the circle. You could kind of do the same thing. In fact, right here you could with this guy, with this big arc, you could do the same thing with the central angle. The central angle is A plus D, right? So central angle is A plus D. So A plus D for the big arc. And then right here you get B plus C, right? It should be the smaller one, so 2 times B plus C. Notice how we have this isosceles triangle. In this case, we'd have an isosceles triangle from here to here, which means that this angle right here is actually B plus C, and this is B plus C, and using the same argument, you can show that A plus D will be equal to B plus C plus B plus C. Okay, so we got that. So we know these two facts, all right? So we know that 2 times quantity B plus C is equal to A plus D. Now, if we're interested in knowing about, we were interested in particular this arc and its central angle and B, right? We're interested in that. So relationship 2A and B. And notice that you can kind of, well, if I were to multiply or distribute the 2 out, I get 2B plus 2C is equal to A plus D. Notice that 2C is equal to D. So See, 2c and d, so they're actually the same thing. They're both equal to, I can replace this with the d, and I have a plus d plus d. I can subtract d from both sides, so they're gone. We successfully did it. A is equal to 2b. Thanks for watching.